Hi, this video is on integrating using the disk method to find the volume. All right, so let's take a look at a disk first. A disk is basically a circle, and we know the area of a circle as pi r squared. And then to find the volume of the actual disk, we multiply by its width. So we have some depth to this circle. So the area of a disk is pi r squared times its width. All right, and so once again, the area of a circle, the volume of the disk is pi r squared times its width. And we're using big R for the radius of the disk instead of smaller. Let's take a look at this figure here, this blue figure. It's a solid figure. And what if we wanted to know the volume of this solid figure? Well, let's first just take a look at this shape here. Do you see that shape there is signified by this graph? If we rotate this shape on the x-axis, do you see? If we rotate this shape around the x-axis, it forms this figure here. And just like integration that we've done before, we started integration by adding up the area of rectangles. We would create a whole bunch of rectangles, and then we'd add the areas up, and we'd find the approximation for the area of the curve. And if we created thinner and thinner rectangles, that means more would fit better into the curve and you'd be more precise, till eventually we fit an infinite amount of rectangles in that curve. We then integrated using an infinite amount of rectangles, and that would give us the exact area. So that's the same thing we're doing, finding the volume of a disk, using the disk method. Do you see? Here's the shape that we want. We're going to put a disk, make a whole bunch of disks for this shape. We find the area for the volume for each disk and add it up, and then we have an approximation for this volume. Now, if we make those disks skinnier and skinnier, thinner and thinner, make more and more disks, once again, you'll fit more in and you get more precise, till eventually you make an infinite amount of disks and you get the actual area. So that's what we're looking at when we say we're going to integrate finding the volume. So once again, the volume is pi r squared times the width, and we signify the width, and we're going to make the width the change of x, the smallest values of x. Okay, so here's, let me talk about the rotating. If you see this, we rotate this about the x-axis. This shape, we rotate it about the x-axis to find the volume. Since we're doing x-axis, we're creating rectangles that go down to the x-axis and up to the graph, x-axis and up to the graph. Now, our rectangles have to go down to the x-axis, and there's nothing to stop it. So there's always a graph there to keep it going. If you look at the formula, we're integrating on the x-axis from A to B. The formula is pi r squared. We can put pi outside of the integration, r squared, and then the dx. Let's take a look at integrating where we're doing the disk method along the y-axis. Do you see along the y-axis, we're creating rectangles that come from the y-axis this time. And we're going to integrate from C to D on the y-axis, C to D. If you look at the x-axis when we did that, our variable is x that we're using. If we're doing on the y-axis, our variable that we need to have is y. So you have to understand, if you're going to rotate it about the x-axis, it would look like this. They call it the horizontal axis, or the vertical axis, the y-axis. You're integrating with respect to y. So here's an example. If I had this shape here, and the actual equation for this shape is the square root of sine x. Now imagine this shape rotating around the x-axis. If it rotates around the x-axis, it looks then like a lemon. If you fill it in and look at it, it looks like a lemon. So we want to find the volume of this lemon, of this shape. We're going to integrate pi r squared and pi r squared, and then the width, which is dx, along the x-axis. And if you look, we're going to integrate from 0 to pi. All right, so let's go to the next slide. It's going to explain it a little bit better. So we put our function into, this is our function, Rx is our function. That, by the way, if you look at that function, it explains our R, right? The radius. If you look, here's the radius of this, of this. So it shows you the radius at each point. You see, this is the radius at each point. So the function is the square root of sine x. That's the radius. We square it. Pi r, this is r squared. Square root and square cancel, and this is what I get. We're integrating from 0 to pi. The integration of sine x is negative cosine. So we integrated it, and this is what we got. First, we have pi. And now we're going to put pi's on the outside. Now we're going to put pi in negative cosine. Then we subtract and put 0 in negative cosine. And we look at our unit table and our unit circle, and the cosine of pi, if you look at the cosine of pi, it equals -1. So we have pi on the outside, there's a negative here, and the cosine of pi is a -1. The cosine of 0, if you look on your unit circle, is 1. Negative, negative here changes to a +1. Negative, negative changes to a +1. 1 plus 1 is 2. So we're left with pi times 2, which equals 2 pi. And that is the volume of that lemon. 2 times 3.14, blah, blah, blah. All right. So I've got 2 more I want to do. First, I'm going to rotate this around the x-axis. That means we're using rectangles going down to the x-axis. Not rectangles now, because that's when we're finding area, but when we find volume, we're using discs. So we're going to rotate this shape. I mean, if you look at it, we're going to rotate this shape. Down here, it's going to go down to -4. We're going to rotate this shape, and it'll look kind of like that around the x-axis. So we integrate from 0 to 2, the x-axis. The formula is pi r squared w. We put the pi outside. R is the actual function for the radius, and they give us the function here, 4 minus x squared. So that's R. We have to square it, times w, which is dx, because we're integrating around the x-axis. So over on the side, I'm going to do 4 minus x squared, which is 4 minus x squared. And I'm going to distribute this or FOIL it. 4 times 4 is 16. 4 times a negative x squared is 4 negative x squared. This is a negative 4x squared. That becomes negative 8x squared. And then negative x squared times negative x squared is a positive x4. So we end up integrating. This becomes x to the fourth minus x squared plus 16. So now I'm going to integrate that, and we're integrating once again from 0 to 2. X to the fourth integrated is x to the fifth over 5 minus 8x to the third over 3 plus 16x. And once again, we're integrating from 0 to 2. So first I'm going to plug 2 into the function. 2 to the fifth power over 5 minus 8 times 2 to the third power over 3 plus 16 times 2. Then we're going to subtract, plugging 0 in. And if you plug 0 into everything, you still get 0. 0 to the fifth minus 8 times 0 to the third plus 16 times 0. So this becomes 0. And I'm going to put the other side on my calculator, in my calculator. 2 raised to the fifth power divided by 5. Minus 8 times 2 to the third power, that's 64 divided by 3 plus 16 times 2, 32. And we get a volume of 256 over 16. And don't forget the pi that's sitting out in front, pi. So when you do that math, you get 256 over 16 pi. Okay, so that was integrating using the disk method about the x-axis, finding that volume. Now, what if I integrate about the y-axis for this problem? If you look at this, it actually turns into if I could have drew it a little better, this will integrate around the x-axis, and it actually turns into a different shape than we had if you integrated around the x-axis. The shape actually looks different. And so it's a different size. I think we'll probably get a different volume when we do this. So we're going to integrate around the y-axis this time. In other words, we're going to create disks along the y-axis. So we will integrate from 0 to 4 this time because we're doing the y-axis from 0 to 4. There'll be a pi. And we have to find the formula for this equation with respect to y. So that means I need to get x by itself. So I'm going to get the 4 to the other side by minusing 4. I have y minus 4 equals negative x squared. I multiply everything by -1, and I get a -y plus 4 equals x squared. Then I need to get x by itself, so I square root both sides, and I get x equals the square root of 4 plus y. I just put the y in front. That should be 4 minus y. 4 minus y. Does that look like a 4 to you? There we go. You see, I just put the 4 in front. So here's the integration we're going to do now. From 0 to 4, here's our, and by the way, this is our r, the square root of 4 minus y. Don't forget, we have to square r, pi r squared, and then dy. We're taking the integration with respect to y in this case. Square root and square cancel. So we're integrating from 0 to 6, and it's going to be 4 minus y because the square root and square cancel. So integrate 4, and I get 4y. Integrate y, and I get y squared over 2. So we integrated this. There's a pi sitting out in front, and we're integrating from 0 to 6. So first I plug 6 in, 4 times 6 minus 6 squared over 2, minus, plug 0 into it all. Once again, if you plug 0 into all of this, you get 0. So 4 times 6 is 24. 6 squared is 36 divided by 2 is 18. 24 minus 18 is 6. So, and then we have to multiply it by pi. So you notice the volume, when we rotate this about the y-axis, we get 6 pi. When we rotate it about the x-axis, we got 256 over 15 pi, which is 17. So you actually get a lot more when you rotate it about the x-axis. The shape actually gives you a bigger volume because you're rotating it. If you look, you're rotating this 4 part, this up 4 all the way around. Here you're rotating 2 all the way around. So it's a different volume either way. Well, this was integrating with respect to x or with respect to y, rotating about the x-axis or rotating about the y-axis using the disk method. I hope this video helped.